Have you ever been confused by something you learned in coding? It can be really puzzling, right? If that's you, then you're in the right place. Today, we're diving into a common question about character pointers in C programming. I totally get it. It can be frustrating when you think you understand a concept, only to find out it doesn't work the way you expected. You're not alone in this. Many new coders face similar challenges. Here's the specific question we're addressing today. One user asked, if char pointers are read-only, why can I overwrite them? They provided an example where they defined a character pointer for a fruit and then changed it from banana to apple. Sound familiar? Let's explore this together. So, what's really happening here? In C, when you declare a character pointer and assign it a string literal, that string is stored in a read-only section of memory. However, the pointer itself is not read-only, which means you can change what it points to. And stick around. At the end of this video, I'll share a quick tip that will help you understand pointers even better. To understand why the user can overwrite the pointer, we need to clarify what a char pointer actually points to. In this case, the user has defined a pointer called fruit that points to a string literal. String literals in C are stored in a read-only section of memory. This means that the content of the string itself cannot be modified. However, the pointer can be redirected to point to a different string. When the user runs the code, the first print statement shows fruit is banana. Then, when the user assigns fruit to point to apple, the pointer now references a different string. In summary, the user has not misunderstood the concept. The char pointer can be reassigned to point to different string literals, but the original string literal remains unchanged and cannot be modified. Fun fact, in C, string literals are immutable, but pointers can be reassigned. It's like having a remote control that can change channels but can't change the show itself. Now, let's look at the answers provided by other users. This user explains that when you declare char fruit and assign it to banana, you're creating a pointer that points to the first letter of the string. When you print it, C reads from that pointer until it reaches the null character. By later assigning fruit to apple, you're simply changing the pointer to point to the first letter of apple. That's all for that response. Let's see what someone else had to say. This user clarifies that char pointers are not inherently read-only. They explain that char const pointers are read-only, while char pointers can be modified. They also mention that string literals should be treated as read-only, but this isn't always enforced. That wraps up that answer. Let's move on to another one. This user explains that when you define a C string using double quotes, the pointer itself is mutable, but the content it points to is read-only. This means you can change what the pointer points to, but you cannot modify the string itself. The user also highlights 3 scenarios regarding pointers and content. First, an immutable pointer with mutable content, like a char array. Second, a mutable pointer with immutable content, like a string literal. Lastly, both pointer and content can be immutable. That wraps up that answer. Let's move on to another one. This user clarifies that your course is correct. When you define char fruit as a pointer to a string like banana, it points to a constant character in read-only memory. When you later assign fruit to apple, you're simply changing the pointer to a different string in the same read-only section. If you had defined fruit as a const pointer to a const string, like char const fruit equals banana, the compiler would prevent you from changing it to apple. This highlights the difference between a pointer to a constant and a constant pointer. Let's take a look at an answer from another user. This user explains that when you assign a new string to the variable fruit, you're not overwriting the original string. Instead, you're changing the address that fruit points to. The compiler keeps the strings banana and apple in separate memory locations. So when you set fruit to banana, it points to one address, and when you change it to apple, it points to a different address. Here's that quick tip I promised. Always remember that while string literals are read-only, pointers can be reassigned. This distinction is key to mastering C programming. And there you have it. Now you understand why you can overwrite char pointers in C. Keep practicing and don't hesitate to ask questions. If you found this video helpful, hit that subscribe button for more coding tips and tricks.